Hey guys, this is a quick overview of the solutions to the homework, page 257, 9 to 14. I actually just recorded all this, me doing all the work, and for whatever reason, the video, so there was an unexpected error when I finished recording it. Spent like 30 minutes doing that, so that's kind of a bummer. But I already have it all written out here, so I'll just go through here and explain it a little bit and go over the answers here. So the first one, number 9, when we're finding our extrema using the second derivative, we first need to find the first derivative, and we get what are called the critical numbers. So that's these 2 points here. I took the first derivative, so those equal to 0, and found my critical numbers, which are the zeros of the first derivative. Then what you do is you find the second derivative, which I've got here, and you plug these 2 points into the second derivative and look at the sign. If the sign is positive, that means it's concave up and there is a relative min. If it's negative, that means it's concave down, there's a relative max. So what I did then here is plugged in 0. I got 0, which meant this test is inconclusive. The second derivative test doesn't work for that particular point. When I plugged in -3, I got a positive, which meant that the function is concave up, so it looks like that. So it helps to even just draw it out, and then you can determine if it's a min or max. You'll see it's concave up, so that's a relative min there. So relative min at -3, and then to find the y-coordinate, what we do is we plug it into the original function. So you do f of -3 to find the y-coordinate, and I got -28 when I did that, so just plugged it up there. Now with this other one, you may or may not have done the first derivative test. It's good to do the first derivative test. If you remember that, the first derivative test, you write these intervals. So we'd have -infinity to our first critical number, which is -3, and then -3 to 0, 0 to positive infinity. And then you plug in test points. So then I plugged in -4 into the first derivative. That was a negative. I plugged in -2 because that's on this interval. I got a positive. Plugged in 1, I also got a positive. So then what we do is look for the sign changes. So we're decreasing to increasing. That looks like this. So that tells us a relative min, which is what we found. The other one, it's increasing, and then it levels off to 0, and it keeps increasing. So there's no extrema there at 0, which is what we found based on the second derivative test there. For number 10, very similar. Take the first derivative, and then we factor out the greatest common factor there of 4x. I set each of those equal to 0 to get x equals 0. The second one, when we solve that one, we get the square root of -2, which does not exist. So our only critical point there is 0. We then compute the second derivative, 12x squared plus 8, and then we plug 0 into that. That is a positive 8, so that tells us it's a relative min at 0. So that's the number we plugged in, not 8, at 0, and then we plug 0 into the original function, f there, and we get 1. So that's where 0, 1. These e's are generally where people get tripped up. They look pretty confusing. They are a little bit confusing, but once you get the hang of them, you just have to have experience with e's in order to get those. But I'll go over these here. For the first derivative here, we wanted to use the product rule. So we took the derivative of x, which is 1, times the second function, plus x times the derivative of the second function, which is e to the u times u prime. So e to the -x times -1. What I did from there, just simplifying it in this step, and then pulled out the greatest common factor there, which is e to the -x, and then set each of these factors equal to 0. So I set e to the -x equal to 0. I'm going to just delete this real quick to illustrate this part a little bit better. So e to the -x equal to 0. The other one is easy, 1 minus x equal to 0, because you just add the x over and get 1. But you might be thinking, well, where does e to the -x equal to 0? And that is nowhere. Because if you look at the graph, that's what I drew here, it never crosses 0. And also, if we were to solve this equation, what you would do is you take the natural log of both sides. The natural log of e cancels, so it leaves with the -x equals the natural log of 0. Well, the natural log of 0 is actually undefined as well, because natural log never crosses 0 either. It looks like this. So that's undefined, which means there's no place e to the -x equals 0. So we just throw that one out. E functions will never equal 0. So then we need to find the second derivative. when I did that, use the power rule here for the first one, e to the negative x times negative 1, minus, so we have to use a product rule to find the derivative of that one, which was the derivative of x, which is 1, times e to the negative x, plus x e to the negative x times negative 1. We simplify this down to negative 2 e to the negative x minus x e to the negative x. We then can plug in our one critical number there, which was 1. So I did f double prime of 1, and I got negative 2 e to the negative 1 minus e to the negative 1. So that just becomes negative 3 e to the negative 1, which we can just rewrite as negative 3 over e. And that is a negative number, right? So that would be concave down, which means there is a relative max at 1, because that's the point we plugged in, comma f of 1, or 1 e to the negative 1. Our next e function is pretty similar, actually easier. Take the derivative there first, using the power rule there, e to the negative x squared times negative 2x. You'll want to just keep these factored separately here and set them both equal to 0, which I did down here. And again, when you set e to the negative x squared equal to 0, that's never going to give you 0, so I just canceled that one out. And this one is simple, it's just x equals 0. The second derivative is maybe a little bit more challenging, but you end up with 4x squared e to the negative x squared minus 2e to the negative x squared. And then you just simply plug in the critical number. When you put 0 into there, we get 0 for the first term. The second term ends up being minus 2e to the 0. Anything to the 0 power is 1, so it just becomes negative 2 times 1, or negative 2. Since it was a negative, that tells us it's a max. So it's at 0, and then we plug 0 into the original function. Up there, e to the 0 gives you 1, so 0, 1. Next part is to rational functions. You have to use the quotient rule in finding these derivatives. Another way would be to just simplify it from the outset. If you just sort of took each of these sections and simplified it, you might have done it that way. You could rewrite this function as x minus 5 plus 4x to the negative 1. Probably didn't do that, though, I'm guessing. Probably did the quotient rule, which is fine. When you do the quotient rule, you take the derivative at the top, 2x minus 5 times the bottom, minus the original top times the derivative of the bottom, over the bottom squared. Just go through and reduce that. We get x squared minus 4 over x squared. With rational functions, the critical numbers are where it's 0 or undefined. So then I set the top equal to 0 and the bottom equal to 0. I got plus and minus 2 when I set the top equal to 0, and 0 for the bottom. So then those are our critical numbers. We now need to find the second derivative, which you can use the quotient rule again. So when I did that, it reduces down to just 8x over x to the 4th. And then we're going to plug these three numbers into our second derivative. So it looks like 8 over x to the 3rd is what our second derivative reduces down to. And so when we plug in negative 2, that gives us a negative 1, which tells it's concave down, so that's a max at negative 2 comma negative 9. When I plug in positive 2, I get a positive, so that tells us a relative min at positive 2 comma negative 1 when we plug it into the original f. And then when you plug in 0, you get undefined, so that is inconclusive there. And with our last one is pretty similar. We'll start by just taking the derivative using the quotient rule. We get 2x times x minus x squared minus 1 times 1. Reduce that down to x squared plus 1 over x squared. When we set the top and the bottom equal to 0, setting the top equal to 0, you get imaginary numbers because you get the square root of negative 1. So we throw those out. We get x equals 0 for the bottom. So our second derivative here, we use the quotient rule again. The quotient rule reduces down to negative 1 over x to the 6th. And we just plug 0 into that, which is inconclusive. It's undefined. So we could use the first derivative test. When you do that, if you were to set up your two intervals, negative infinity to 0, 0 to positive infinity, you get they're both increasing. So it's just increasing, levels out 0, increases some more. So there's no extrema with that last one. So hopefully that cleared things up a little bit. You can at least check your answers. If you still are confused, make sure that you do reach out to me. Thanks.